In this short video, I'm going to quickly walk through a list of key concepts in SNA. And the reason I'm doing this is because people use those key concepts differently in different contexts, mostly because they are coming from very different backgrounds. For example, some might be coming from mathematics, and some might be from sociology, some might be from education, so they might use terms very differently depending on the specific background that they're coming from. So that will cause a lot of confusion for us because we might expect two very different words to mean different things, but eventually in SNA they might mean the very same thing. So in this video, I'm just really quickly want to glide over those and then try to skim the surface so that we can be a bit more prepared when we dive into the books or further reading in this course. So let's get started. And the first part, I grouped them under the word actor. And what it means is actually, for example, when you're talking about social network analysis, when we think about a diagram or a visualization of a social network, and the key unit in this diagram could be for example, people, then they form different nodes that are interconnected in this network. So what I mean by actor is the nodes within a network. And as I mentioned, I already used the term node already. And so people could mention that as node, as vertex. Actually, I made a mistake. It's called vertex is the singular form versus vertex as the plural form. And some other people use ego, and some other might mention them as agent. So those terms are packed with different background information. And for example, agent, you might expect more from sociological research when we talk about power, when we talk about relationship among people and the institution or established institutional rules built into this society. So you might expect more of that term. And if you're coming from mathematics background, you might expect terms like vertex a bit more. So, but in SNA, they might just mean the very much the same thing, even though there are information packed in those different terms. So when you come across those different terms, right now you should feel prepared and you know what they mean. And let's move on. And if you, for example, talk about different actors or different nodes, there are usually attributes behind them. For example, I was just drawing a dot. For example, I can use that to denote a student in my class. And I can use a different color. For example, I use red to mean female students. I use green to mean male students. So the gender becomes an attribute that's behind each of the actor or each of the node. Or I can, as I already draw, there are different sizes. You can use the size to mean different things. And those are attributes coming with or used to describe different actors in the network. And you will definitely encounter those the use of attributes in SNA. So just add in a little bit more information to the actors, and you can do a bit more in SNA eventually. And moving forward, we mentioned about the nodes, and they could be of different sizes, different attributes. They could be mentioned as vertex, it could be mentioned as agent, ego, etc. And another part of social network analysis, as we already talked about in the earlier video, is we are really concerned about the links between them. And in many cases, they are referred as link. For example, I mentioned them as link, and it could be described as ties, relations, interconnections. And if you're talking specifically about visualization, it could be mentioned as an edge or a line. So you can draw with other um, with other nodes like this. And I realize some researchers, they're trying to distinguish between edge and an arc, and trying to use edge to mean a line without any direction. So right now what you see in this slide are 3 different lines without any direction. But if you can add information onto each line, for example the green line, the only green line, if you add this direction from this bigger red dot to the smaller red dot, that means there's a direction with this line, and that becomes an arc for some researchers, even though I'm not really using that in that way, because I prefer to be more specifically saying this edge is directed, or this link is a directed link, versus the other link is undirected link, or the whole network is directed or undirected. So there are different ways people use to describe or to characterize the ties, and so be prepared for those. And I think just going through this video, you can get a sense of it. So again, just like what we talked about in the last slide about the actors, there are many ways to describe the ties. And for example, in a classroom, we can have many different kinds of ties between 2 nodes. There's a node A and there's node B, and for example, we can specifically build ties or recognize tie between A and B. For example, A lend a book to B, and that becomes a directional link from A and B. Or it could be also B lend a book to A. That could be another tie. And in a network, you can expect to have other kinds of ties within the same network. For example, you can say A also, in addition to lending books to B, also, for example, ask B to go out for lunch. Just brainstorm an example. That becomes another kind of tie in this network. Or you can even have another kind of undirected link. You can say A and B, they are sharing a bus when they are going home. And this is another different kinds of tie that you can build in this network. And in addition, I mentioned there's another term called weight that basically describes the strength of each link. For example, this link, in a visualization, you can make it thicker to mean the weight is stronger, right? And versus in a different scenario, you use a thinner link to mean that the tie is weaker. And for you, when you're going through SNA, when you're doing SNA in this context, you need to make many kinds of decisions when you're either creating those links or organizing those links. For example, one very important decision you need to make is whether it makes sense to keep those different kinds of ties in the same network, or do you need to separate them into different networks. And those should be always situated in a specific research question you're asking, specific research context, and even theoretical framework you're drawing from. But here, in this video, I'm focusing on different kinds of terms you might encounter in those different kinds of research you'll be reading about. Moving forward, we mentioned about node and ties, and this is going even upper level, is about the whole network. And even for a network, there are different terms. For example, there are people referring network as a graph. If we're talking about specifically about visualization, it could be mentioned as a sociogram, which is more used to describe a visualization of social network. And also a social network could be represented as a matrix. and that's very important, especially if you're going to do any kind of computation. So if you're not concerned with computation, matrix is not a required concept for you. But if you're going to do, for example, calculating a bunch of SNA measures, then matrix is a very, very important part of SNA. Even though modern computers and modern algorithms, they are already built for you to do that task, but knowing network could be represented as a matrix is critical as well. And under network, there are many different kinds of network. For example, we're going to actually dive into one type of network. It's called ego network. And also there are different modes in a network. And by mode, that means, for example, I mentioned about a student network. This could be a student A and student B. And if we're concerned with the links or the networks among students, then that's only a one node network. And I mentioned books, right? And if we add books into this network, for example, we can try to investigate student A read a book and student B also read this book. And if we add book and student into the same network, that becomes a two-mode network. And the mode means basically the types of nodes that exist in the same network. And that's not something we're really focusing on in this course, because this is an intro to SNA. That's more advanced SNA concepts. But if you're interested, feel free to explore more. And I mentioned about matrix. Even if matrix is a pretty clear concept mathematically, I think, but still people are mentioning it very differently. People use, for example, tables. Some use list or data frame. If you're specifically using R, they are very close, even though there's some slight differences among those terms. But people simply use them as the same concept when they're talking about SNA. And even when you read this book when you read the textbook, you even will say the author using array or vector to mean matrix. So there's no standard way of referring matrix in SNA context. Just be prepared for those different terms when you're reading this text. And I already talked about the importance of matrix. It's important for data collection. For example, when you go to a field, and usually the way you collect data is actually putting the data into a matrix or putting that into a table. And then for computation, it's critical. And then visualization is grounded on the matrix-based SNA data. So that's also that's just about matrix. And going forward, I already mentioned there's a lot of different choices you make when you're doing SNA. The choices of how many different kinds of ties you want to keep in the same network, and how many different kinds of actors you want to keep, and which kind of algorithm you're going to use to visualize your network. So those choices are critical for SNA, and the whole purpose of this course is to help you to make informed choices, informed decisions in SNA research. And I just want to highlight that in SNA there's no formula that you follow to do specific techniques or to do specific tasks. Instead, we're trying to bring different perspective together. It could be analytical perspective, it could be theoretical perspective, philosophical perspective, practical perspective, together to form a feasible or appropriate solution to your problem of understanding. So expect to make a lot of choices and to think about choices, because from my point of view, choices are more important and are more difficult instead of more difficult compared to acquiring some kind of knowledge, because when you're making choices, you're activating knowledge in the same time you're also you're activating the knowledge, you're drawing from different pieces of knowledge, so the complexity of making choices is far more higher than memorizing some kind of knowledge about SNA. So please expect to make a lot of choices in this course. And I think that's all I want to cover in this video. Thank you for watching.